Okay, welcome back to Rational Exponents. I said we would continue on with applying our rules and definitions to variables, and that's exactly what we'll do. So if we have rather than some numbers, right, we're just using variables. So if I have x to the fifth being multiplied by x to the fourth, how would I go about evaluating that? What I want to do is that I want to rewrite this radical using my definition. So I have x to the fifth, which is being multiplied by x raised to the 4/2 power, okay? And 4 divided by 2 is 2, so really I have x to the fifth times x squared. And using rule number 1, since I have the same base but different powers, so I have 5 and 2, what I do is that I just simply add them together. So x raised to the 5 plus 2 power, which gives me x to the 7th power. If I have the cube root of x to the fifth being divided by the square root of x to the third, what I have to do is that I have to rewrite both of these radicals using my definition. So I have x raised to the 5/3 power and x raised to the 3/2 power. And so from here, I can apply my rules, and this is similar to rule 2, okay? Same base, but different powers. So I can subtract the exponents. So 5/3 minus 3/2. What I have to do is that I have to find a common denominator, and the common denominator for 3 and 2 is 6. So I would multiply this first fraction top and bottom by 2, and then this fraction top and bottom by 3. Okay? So 2 times 5 is 10, and 2 times 3 is 6. So I have x raised to the 10/6 power subtracted by 3 times 3, which is 9, and 2 times 3, which is 6. So I have x raised to 10 divided by 6 minus 9 divided by 6. And since I have the same denominator now, I can just subtract the numerators. So 10 minus 9 is 1. So I have x equal to 1 divided by 6, or x raised to the 1/6 power. The next thing that we want to look at is the fourth root of x raised to the 3rd power times y raised to the 5th power. And what I want to do is that, again, I want to use my definition and rewrite this radical as x raised to the 3rd power times y raised to the 5th power raised to the 1/4 power, okay? And this is an application of rule number 4, or I'm sorry, rather rule number 3, right? I have two different numbers raised to the same power, so then I distribute that power to both of them. So I have x raised to the 3rd power times 1/4 times y to the 5th raised to the 1/4 power. And so from here, it's just using rule number 4 now, okay? So I would have x raised to the 3/4 power, right? Because 3 times 1/4 gives me 3/4, times y raised to the 5/4 power. And the next thing that I want to look at is taking the root of a root, okay? And so what that means is if I want the cube root of the square root of x, how would I go about rewriting that? Well, the thing that I want to focus on is the inside here first, right? So I want to figure out a way how to rewrite the square root of x. And using our definition, we can say that, let me fix this, change that back to black. So if I have, to rewrite the square root of x, all I have to do is recognize that it's x raised to the 1/2 power, okay? And so using that logic, I can get rid of this cubic root by doing the exact same thing. So I have x raised to the 1/2 power, which is raised to the 1/3 power, okay? And this is another application of rule 4. So all I have to do now is just multiply the two powers together. So x raised to the 1/2 times 1/3, which would give me x raised to the 1/6 power. And finally, if I have 5x minus 6 raised to the 5/3 power being divided by the cube root of 5x minus 6 squared, how do I go about solving this? So what I have to do is that I have to rewrite my denominator, okay, using my definition. So I have 5x minus 6 raised to the 5/3 divided by 5x minus 6 squared, which is raised to the 1/3 power, okay? And this is an application of rule number 4. So I multiply 2 times 1/3, and what I will get is, if I write it down here, I have 5x minus 6 still in my numerator, raised to the 5/3, raised to the 5/3, fix that 5 there too. So I have 5x minus 6 raised to the 2/3 power, okay? So from here, this is an application, if we go back to our table, of rule 2 here, right? So I have the same base, which is 5x minus 6, but they're raised to two different powers, okay? So all I have to do is subtract the powers. So I have 5x minus 6, which is raised to 5/3 minus 2/3. So they already have the same denominator, but different numerators, right? So all I have to do is just subtract the numerators. So I have 5x minus 6, and 5 minus 2 is 3, so I have 3 over 3, and 3 over 3 is 1. So my answer will then be 5x minus 6. If we can take a look at one more. So if I, oops, I know what the problem is here. The second button on my color scheme changed. Okay, so if I take a look at one more example, if I just make this up, so if I have, let's do 2 minus 3x raised to the 5/6 power divided by the 4th root of 2x minus 3x cubed, okay? This one I have no idea what it's going to be. So I take my denominator and rewrite it. So I have 2 minus 3x raised to the 5/6. Whoops. Want to divide that. So raised to the 5/6 power. And this is 2, whoops, just 2x. 2 minus 3x raised to the 3rd power, which is then raised to the 1/4 power, okay? So then I have to multiply my exponents together. So I'll get 2 minus 3x 5/6. And then I have 2 minus 3x raised to the 3/4 power. So not only do they have different numerators, but now they have different denominators. So what I have to do is that I have to figure out what their least common denominator is, okay? So 2 minus 3x raised to 5/6 minus 3/4. So the least common denominator for these two guys is 12. So I have to multiply this fraction top and bottom by 2, and this fraction top and bottom by 3, okay? And when I do that, I end up with 2 minus 3x, which is raised to 10 divided by 12, minus 9 divided by 12. So now they have the same denominator, so I can just subtract the numerator, which would be 10 minus 9, which gives me 1. So I have 2 minus 3x raised to the 1/12th power. Okay, that does it for this topic. Next time we will continue on with radicals and calculators. So that's all about using our calculator to evaluate some irrational numbers underneath the radical. Alright, see you next time.